Hi friends, hi everybody. This is Dr. Chukka Santhaiah, Associate Professor of Computer Science and Engineering, Institute of Aeronautical Engineering, Hyderabad. Today concept is designing a learning system, final step. And continuous is perspectives and issues in machine learning. In previous lessons, we discussed about the designing a learning system. Up to 4 steps are we discussed. The first one is choosing a training experience. Second one is choosing target function. Third one is choosing representation of the target function. And fourth one is choosing function approximation algorithm. And final one is designing a system. In the first, we are mainly discuss about the training experience. Means types of the experience, training experience. Second one is we can select the target function, means about the best move. And third one is we can represent the target function. How we can represent the target function? By using LMS and least mean square algorithm and adjusting the weight values. And fourth one is choosing function representation. Means here also we can use some adjustments. And the last one is final designing of the learning system. What is the initial? Means the previous sessions I discussed about we are designing a learning system. What is the main purpose of the learning system? Here learning system is nothing but we implement a program. You can write a code to play the checkers game with system, or maybe the system can be play a checkers game with opponent, like means human being. Or the machine, or maybe human may try to participate in the competition. We are designing a system. For the design purpose, we follow the 5 steps. First one is choosing a target, choosing training experience. Second one is choosing target function. Third one is choosing representation of the target function. And fourth one is choosing a function approximation. And last step is final designing. In this final designing, we already discussed 4 components are there, 4 models are there. In the 4 components or 4 models, it starts from the, here we take some anti-clockwise direction starting. The first step is, the first component is performance system. In this performance system, what it is happened when we try to design a system? Means, in this performance system, we can observe this figure. It receives some input from the previous step, that is about the previous component. That component is called experiment generalizer or experiment generator. Means the performance system is receive the input from the experiment generator as a new problem or initial game board state. Whenever it is the performance system is received input from a new problem from the existing in the previous step or previous component, it does something. It is internally make some operation. Means we can make some operation internally. It produces some output. That output is called solution trace or game history. Whereas the solution trace or game history means if the performance system is issued a new problem, for example, for the new problem, it try to find the new solution, means new. Why? Because it is a new problem as well as new solution is required. In case it is existing problem, in that context, the performance system is search for the solution trace or game history. Means, is there any existing problems? Means this problem is matched with the existing solution. It automatically provides the existing solution as it is without any delay, without any issues. That is the thing about the solution or solution history. Solution trace or game history. So finally, the performance system is received some input from the as a new problem. it makes some operation internally in the performance system and produce some output. That output is in the form of the solution trace or game study. If problem is new, it provides some solution. It provides the new solution. The problem is existing. We may provide the existing solution based on the game study. Means it is trace out. The same problem is raised in the previous days or in the existing one. It is existing one is there automatically give us some solution based on the historical information or historical data. That means the performance system is generate some output. That is about the solution trace or game study. That output is become as an input to the critic stage or critic component. Means the critic component is second component or second model of the designing a system. Means in the final designing step, the second component is critic. Means it is thinking about the solutions. Means it is the solution as input to the critic stage. There in the critic stage, it provides a solution. Means it is actually observed some existing solutions as well as new solutions. From the based on the analysis about it is provided some output. That output is the critic output is produce some output. That output is nothing but a training examples. Means here critic component is receive the message, receive the output, receive the input from the performance system as a solution trace. And internally do some operation, some operation in the critic component, and it generates the output as in the form of the training examples. Here, training examples is nothing but a B1, that's the first stage, board state. As well as first board state training value, comma, second board state, and second state, board state training value, and so on. Means some training examples is generated. Means the critic component is produce output. That output is in the form of the training examples. This output, the critic output, is input to the generalizer. That is about the third model of the final designing assist learning system. Third model means the generalizer is receive the input from the critic stage as a training examples. Based on training examples, it produces some output. That output is called hypothesis. Here, hypothesis is nothing but a maybe or may not. Means may be correct or may not be correct. Hypothesis. Basically, meaning is may be correct or may not be correct. May success or may not success. Hypothesis means that hypothesis also represented as a target function. Means in this hypothesis, the generalizer is produced it receives some input from the critic as a training examples. In generalizer, we can perform some operation in this generalizer with the training examples and produce some output. That output is in the form of the hypothesis. Hypothesis is nothing but a maybe or may not. Initially, present condition, we face a lot of problem, especially about the COVID situations, coronavirus. In this coronavirus, means first wave, second wave, as well as there is chance for the third wave also. The first wave has some symptoms, as well as second wave has some symptoms, and third wave also have some symptoms. But somebody says, the first wave is completed, second wave is also completed. Somebody says, there is no chance for the third wave. Some experts says, there is a chance for the third wave. Means here hypothesis is there. There is evidence about there is maybe there or may not be there about the COVID-19, coronavirus third wave, COVID third wave. Why? Because based on some sequences, based on some internal reactions in the COVID coronavirus structure, there is chance for the second wave automatically proved. Why? Because the coronavirus has only RNA structure, no DNA structure. It has RNA structure, no DNA structure. Whereas come to the RNA structure dynamically change. Means dynamically change based on some mutations. That mutations may be internal reactions or may be external actions, external force. So based on that, some experts says or maybe give some hypothesis. There is a chance for the third wave. Somebody says there is no chance for the third wave. There is chance for the third wave based on its mutations internally. There is no fixed structure. So based on that, after some duration, after some time, some mutations, internal mutations will take a place in coronavirus structure. Based on the mutations, there is chance for the third wave as well as there may be adding some more chance about the symptoms. As well as there is no third wave. Somebody says, hypothesis, may not. Maybe there, some evidence is there. Why? Because some based on mutations. As well as may not. Says, some evidence also there. Means, after 3 months or 4 months, the second wave will be, after completion of the 3 or nearly 6 to 8 months, it is generated. Means, second wave will be automatically immediately affected and so many people are affected by the second wave. But whereas come to the third wave, it takes some duration. Up to some time it is correct. Means there is no third wave chance. That type of assumptions, that type of the things is called hypothesis. Means in this generalizer, it produces output. Especially training examples means based on some examples, it gives some conclusion. Maybe or may not. So whenever the generalizer generates the output as a hypothesis, that hypothesis received the fourth component, that is about the experiment generator in designing system, final designing system. Means the experiment generator is received the input from the generalizer as hypothesis. Here experiment generator is produced, means may be correct or may not be correct. Means the hypothesis right. Then again you can produce the hypothesis wrong. It becomes as somewhat means same problem. So like that it is produced. Means after receiving some input from the generalizer as the experiment generator is receive the input from the generalizer as hypothesis. There itself it is conduct some analysis internally and produces output about the new problem or initial game board. Means the problem is solved. Again the new problem is generated. Automatically this becomes a new problem. And the problem is not solved. Again we start from the initial game board, means starting stage. This is the 4 components are there in final design system. First one is performance system. It takes some input from the input from the as a new problem or maybe initial game board and produce some output like in the form of the game solution trace or maybe game theory. The same output goes to the second component, that is about the critic as input. In that input stage, there is about the critic component. It makes some operation in that and produce output for as a training examples. The training examples also goes to the input to the generalizer. There itself makes some operation and produce output as a hypothesis. That hypothesis goes to the next component, that is about the experiment generator as an input. There itself makes some operations about the hypothesis, correct or may not be correct. Then becomes a new problem or will be existing problem. This is the process is there in designing a learning system based on the final step. The final designing of our Chukka's learning system can be described by 4 distinct program models that represents the central components in many learning systems. Next we discuss one by one what is the basic main objects, main process is going on each and every component of the design system. The performance system. The performance system is the model that must solve the given performance task by using learned target functions. It takes an instance of new problem, new game as input, and produces the trace of its solutions, game history as output. Means the first performance system model is nothing but a give the some, it is fulfill the to reach the target function. Like it takes some input as a new problem to the system and produces the output as a solution trace. Next one is critic component. The critic takes as input from the history or trace of the game, means trace of the solutions, and produces as output set of training examples of the target function. And third step, that component. The generalizer takes as input training examples and produces an output hypothesis, that is estimation of the target function. It generalizes from the specific training examples, hypothesis generalized function that covers these examples and other cases beyond the training examples. And fourth one is the experiment generator takes as input the current hypothesis, currently learned function, and produce outputs as a new problem, that is about the initial board state or for the performance system to explore. Its role is to pick new practice problems that will maximize the learning rate of the overall system. We discuss, when you observe this figure about the final designing process, there is a continuous process is there is a continuous relationship is there in this final designing process. Means, for example, takes example about the software development process, especially based on this pictorial representation or components and its relations. There is some software development paradigm is there, that is about the spiral model in case. Means that spiral model is represents as a spiral. Means we can start the initial problem, we can trace it, and it is comes like this. Means there is a chance for the modifications or maybe adjustments or suggestions are there in this software development. Again, we can take some second iteration, means we can start from the here, means some modification they run in the existing one, or maybe some drawbacks are there, finding some drawbacks are there. Again, we can start the one more iteration, means one more development. Again, we can start. Means this extension shows there is chance for the flexibility, there is chance for the modifications or maybe suggestions. Means here it is here itself. Whenever we can start the problem, means from the performance system, critic, generalizer as well as hypothesis, here we can finalize some solution. Up to some level, it is standalone as a new solution. After some duration, some drawbacks are found out by that solution. Means like about the some drawbacks about the finding some solution. Means in case we are getting some, we take some example about the antiviruses. That antivirus have some up to somewhat has some expired period. Means in that expired period, it has some sequence of events. Means it has some expiry date. Whenever after some duration, automatically the hackers are trying to find some issues or loopholes on that antivirus or maybe some drawbacks on that antivirus. It reveals and it is cracked that antivirus. Again, it becomes a new problem, already existing one, but new problems are raised. Again, we can start the one more iteration. Again, we can start the one more designing process step. Like that. Means it is not a stopper process. Continuously running. Especially one main advantage about this software development. Software is very, very flexible. Disadvantage. The software is very, very flexible. It is disadvantage. Why? Because day by day technology is developed. Day by day technology is increased. And day by day it modifications required in technology or development or innovation things. That's why there is a lot of things are there in software development process. So like that, we can propose anything. It must have some limitations. Up to some level it is standalone. From there itself, it goes to the various development stages. Means, in performance system, we discuss some, especially new problem is a take as input and produce output as a solution trace or solution. Means, in this performance system model, we take input. Means here, input is there in the first one, performance system. Means it takes new problem as input. Means is your input is new problem in the performance system. And output is solution trace or game history. Right. And second step means critic. Second component. Here is also input is takes solution trace. What is the output is in the previous component, it becomes input to the next component or next model. And output is training examples. And third component is generalizer. In this third component, it takes input as a training examples, means generalizer. It can take input as a training examples, means what are the output is generated by the critic component. It takes input to the generalizer component, training examples, and produce the output like hypothesis. It is also called target function, means VCAP. That is about the input and output of the third component of the designing system. Final designing step. And fourth component of the final designing step is experiment generator. Here experiment generator. That experiment generator takes input as hypothesis and produce output like a new problem or initial board state. This is about the designing a learning system final step explanation. Means here we discuss about the four components of the final step about the designing a learning system. So based on this conversation, based on this discussion, we produce a output. Means once again I can repeat some steps about the before go to the Next concept, that is about the choosing the training experience. Second one is target function, choosing target function. Third one is choosing representation of the target function. And fourth one is choosing function approximation. And final one is designing a system. Whereas come to the training experience means we can take some training. It is a play a major role to select the target function. And we can represent the target function. It is a very, very helpful on the target function representation. And function approximation, choosing function approximation algorithm. Here also we can reduce some weights, errors rates. And final designing step, we discuss 4 components. So finally, we are designing a learning system with the 5 steps. Choosing a training example, choosing target function, choosing representation of the target function, choosing function approximation, and final design. Then we are designing a system. Right. Next one is perspectives and issues of machine learning. What are the various perspectives are there and issues are there in machine learning? When I discuss about the perspective, means perception or perspective. Perspective, perception means this perception is differs from the person to person, as well as perception is depends on the person thoughts as well as person knowledge. Means, for example, I can observe the perception of the students in the classroom. I can draw a one symbol on the blackboard. That is about the blackboard. And then I can try to ask the students what it is indicates, what is this. There are nearly 60 students are there. 60 students are observe that figure, that symbol, and 60 students are trying to give the answer. Some students maybe it is a 0. Means some students, based on some student perception, it is a 0. Numerical value. Some students is represents, it is a O. Alphabet order. Alphabets. Somebody sir says, sir, it is a circle. Or somebody sir says it is somewhat oval. Means simply I can draw some symbol on the blackboard. Different persons are perceived different ways, their own awareness, their own knowledge. Like that, what is the meaning of the perceptives in machine learning? Right. And what are the various issues are there in machine learning? Here issues is sometimes is called issues, sometimes is called challenges, sometimes is called targets, sometimes is called problems. So first we discuss about the perspective, then we are going to the issues in machine learning. What it is contains. One useful perspective on machine learning is that it involves searching a very large space for large space of possible hypotheses to determine one that best fits to observe data and any prior knowledge held by the learner. Means in a special one useful as well as very useful and needful perspective in the machine learning involves searching a large space possible hypothesis. That hypothesis to determine the best fit the observed data and prior knowledge held by the learner. Means, it says here in this perspective, the main perspective of machine learning is there is a lot of number of issues, the lot of number of hypotheses there. From that hypothesis, we are select the best one. Means best thing or best one is we can find out. That best one selection is based on the prior knowledge about the learner. For example, take some example about the prior knowledge about the learner, and it can give some best bit, best fit, or best move, or best possibilities to win the game, or best possibility to prove the hypothesis correct. We can select. We can take some example that is about the checkers board, for example. You can take checkers board is actually contains 64 by 64 rows as well as 64 columns. For example, the board state is here itself, in case. Board state is there, in this current board state is here. Means there is a large space of possible hypothesis. Means here we can space is there. Here we simply represent 5 by 5 and 5 into 5. But whereas come to the checkers game, nearly 64 rows as well as 64 columns are there. Large space, large search space. Means large search space of the possible hypothesis. Means we can imagine this is a one possible to win the game. It is a one hypothesis. As well as it is also one of the hypotheses. As well as it is also another hypothesis. It is also one more hypothesis to win the game. Means you have number of options are there. Means it is a near large search space. We have some hypothesis. From that hypothesis, we select the best one. Best hypothesis or best possibility. Based on the best possibility to identify the best possibility or best hypothesis. It depends on the prior knowledge about the learner. Means the learner have the good experience, training experience. Automatically have some select the best one, best or best fit. Means best possibility to win the game or best possibility to success the game. That is about the perspective. Means especially the main objective or main useful perspective about the machine learning is there is a number of possibilities are there. Number of hypotheses are available to find the solution for the complex problem. From that number of hypotheses, the learner is find the best solution or best possibility, best answer for the complex problem. That selection of the best problem, that selection of the best solution, it is depends on the trainer, learner experience or learner peer knowledge. Here, peer knowledge is nothing but a training experience about the learner. That is the main perspective about the machine learning. Means number of solutions are there for the complex problem. From that, we are selecting the best problem, best solution. That selection of the best solution is depends on the learner experience or maybe trainer experience, learning experience, and prior knowledge about the games. Next, issues. Next one is issues in machine learning. What are the various issues are there in machine learning? This issues is called, sometimes is called problems, sometimes is called issues, sometimes is called challenges, sometimes is called targets. For example, we can take some of the computer network subject. Suppose we try to design a network according to the OS reference model. We try to implement the physical layer, data link layer, as well as network layer, transport layer, session layer, presentation layer, application layer. 7 layers are there. In each and every layer designing, there is some issues are there. Means before you can start the implementation, or before you can start the implementation or designing process, we need some targets, we need some issues. Means we are confident of some issues. Like that, what are the various issues are in machine learning? Whereas come to this machine learning issues, we discuss once again, we can recollect the definition of the machine learning definition. The machine learning is nothing but a machine can be enabled. Means the machine can be enabled. Means machine learning is machine can be enable. Means machine can enable, system can learn automatically and improve its performance. Improve performance based on its experience. And third one is make some predictions. Without external effort or external programs. We have simply defined machine learning is an automatic learning process based on historical data and make some predictions and try to improve some experience based on the performance. Whenever you can clean observation about this definition about machine learning, mainly three concepts are there. The system can be automatically learned from the historical data. And second one is, it improves the performance experience. It improves its performance based on some experience. And third one is making some predictions without any external programs. Three issues are there. Three key concepts are there, as well as three things are there in definition. Whenever we discuss about the machine learning issues, there is a number of issues are there. The system can be learned automatically. How it learns? In which algorithms you are used to learn automatically the machine can be learn it. What type of algorithms are there? It can be used for the learning process. And second one is, it improves its performance based on some experience. Means it makes some operations, do some performance and improve its performance. How it is improves its performance? What type of methods it can be used? Or what type of the issues are there in the improve the performance about the machine? It is another issues are there. Means some more issues are there in that issue. And last one, it makes some predictions without external programs. How the machine can make the predictions without any external force or without any external programs? What type of the techniques are used? What type of which analysis are performed before make any decision over some complex? It is also one more issue. Means whenever we discuss about the machine learning issues, there is a lot of parameters are there. We discuss about the machine learning issues. Each and every one is at their own significance, like in that issues. The first one, what algorithms exist for learning general target functions from the specific training examples? The first issue means what are the existing algorithms are there for the learning about the target function from specific training examples. What type of algorithm can be used? What are the existing algorithms? What are the type of the algorithms are there to find the target function based on some training examples? What type of algorithm can be used to learn to find some target function based on the training examples or specific training examples? Means we try to find some target function based on the learning mechanism from specific training examples, some feature examples. How it is find out? How it's find? So, like that, what type of algorithms are used for the finding the target function from the specific training examples? It is one issue. In what settings all particular algorithms coverage the desired function given sufficient training data? Means we try to decide output or desired solution. We are given some sufficient data. We are given some sufficient training data. Means we provided some sufficient, means according to the machine learning concept about the database analysis, we give the more data to the machine, we expect the more performance. and we give some less data, we expect the less performance. So like that, whatever we can give some training to the machine, how much we can provide the sufficient training data. In what ways we can provide some sufficient data? Or in which algorithms we can train it, we can use some training data. Right. And which algorithms performs best for which type of the problems and representations. Means which algorithms are used to make some best performance. And which type of the problems and which type of the representation is used in the problem representation or best algorithms. This about some issue. Next. How much training data is sufficient? To get the training experience, good training experience, and to try to win the game, as well as to try to success, how much training data is sufficient? Means we can decide how much training data is sufficient for the learner, army trainer, or mission. And what general bounds can be found to be related to the confidence in learning hypothesis to the amount of training experience and character of the learner's hypothesis space. Means we can find what the boundaries are there about the learner confidence level, especially about some hypothesis. And training experience also. And character of the learner's hypothesis space. Means what type of boundaries are there about means what are the boundaries are there? The learner will become some confidence based some hypothesis, and how much type of the amount data training experience is required to get some confidence, as well as how much types of character means learner's character hypothesis how we can define hypothesis characteristics. Next. When and how can prior knowledge held by the learner guide the process of generalizing from examples? Means when and how means how we can use when and as well as how we can use the prior knowledge, especially to find the solution based on some examples. Means when and how prior knowledge is helpful to find some solutions from the general examples. What type of knowledge, what type of prior knowledge is useful, and when we can use prior knowledge to find some solutions, and how we can use some prior knowledge to the learners, and can prior knowledge be helpful even if it is only approximately correct? Sometimes the prior knowledge, based on the prior knowledge, we can correct finding the correct solutions. Means it is sometimes is correct, sometimes is sufficient for the prior knowledge. Sometimes is not sufficient. Means when we can finalize prior knowledge is sufficient. Next. What is the best strategy for choosing useful next training experience? And how does the choice of this strategy alter the complexity of the learning problem? Means, what is the best strategy for choosing the next training experience? This next training experience means, according to Chukka scheme, next move. What best strategy is useful for the next move in the Chukka scheme? And how the choice is this strategy alter the complexity? Means, some number of near means there is a chance for the nearly approximately the chance for to win the game. What type of the knowledge or what are the best strategy is there to find some better one? Means best moves, and we can learn some complexity problems. Means number of issues are there, number of alternative possibilities are there to make any movement. From that moment, we require some knowledge. Means what are the knowledge is useful, and what are the training experience is useful for the next move, means next step or next solution. Right. Some more issues in the myself. What is the best way to reduce the learning task to one or more function approximation problems? Means how we can reduce the learning task by providing approximation problems. Means what is the best way to reduce the learning task? Means we can reduce some training examples to get the best learning process. based on some function approximation algorithm, And put another way, what specific functions should be system attempt to learn? Means what specific functions should be system can be attempt to learn. What type of the symptoms, what are the specific functions are used to? The system can be learned automatically. Or the system can be make some predictions automatically. And can this process itself automated? That learning process or the training experience or make some predictions as well as performance is improved. It is automated by itself. Right. How can the learner automatically alter its representations to improve its ability to reference and learn the target functions? Is there any chances there? How the learner can be change the representation to improve the ability to reference dynamically to find the target function or to learn the target function. These are the issues are there in machine learning. Up to now we discussed about the final step of the learning system, designing a learning system. Here we are discuss about the 4 components, 4 models: performance system, critic, generalizer, experiment generator. There is sequence relationship is there in this. There is sequence relationship is there in these components, each and every one. One component is depends, one component input is goes to the, one component output goes to the input to the next component. Means the first component output is goes to the second, goes to input to the second component. Means the first component output is goes to the input to the second component. And the second component output is goes to the goes to the input. The second component output is goes to the third component as a input. Again, the third component third component input output is goes to the input as input to the fourth component. Means there is a sequence similarity as well as there is somewhat relationship is the cyclic process is there in that designing system. After then we discuss about the various issues in the machine perspective as well as issues in the machine learning. Right, thank you. Thank you, Unadal. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.